Good afternoon, viewers and listeners. Welcome once again to Salida TeleRadyo of La Filipina National High School. I am your teacher host, Sir Richard S. Binyas, and this afternoon, you will learn many things about combination. Lesson in Mathematics 10, Quarter 3, Module 2. Are you all ready? Let's give the floor to our teacher broadcaster, Sir Nemuel June B. Astakaan.
Thank you, Sir Richard. Good afternoon, mga kastig. Welcome once again to Salida TeleRadyo of the La Filipina National High School in cooperation with 98.3 Gold FM, ang radyo astig ng tagong Kuya Wano. I am your teacher broadcaster, Sir Nemuel June B. Astakaan. And this afternoon, you will learn about combination, lesson in Mathematics 10, Quarter 3, Module 2. As we start, prepare yourself learning module and pen and paper. Alright? Our target is, at the end of the lesson, the student should be able to solve problems involving combination. Before we start, let's have an activity. Examine its situation and identify if the statement is a permutation or not a permutation. Again, examine each situation and identify if the statement is a permutation or not a permutation. Number 1. Assigning seats to students. Again, assigning seats to students. Number 2. Picking 2 balls out of 5 balls from the box. Picking 2 balls out of 5 balls from the box. Entering the pin of ATM. Number 3, entering the pin of ATM card. Based on the activity, situations 1 and 3 are examples of permutation in which order of arrangement are important. Both 1 and 3 requires order of arrangement. Why? For number 1, assigning seats to students, it requires order, especially during NAT or National Achievement Test. Each student has their own corresponding chair. And for number 3, pin of ATM card also requires orders. Because if the order of numbers of your pin was disarranged, surely you cannot transact. Well, situation 2 is not a permutation because the order of arrangements are not necessary. Picking 2 balls out of 5 balls from the box does not require order because it's just picking 2 balls with no certain arrangements. Or it is also called combination. Before we solve problems involving combination, we will identify first the parts of each formula. But you write first the formula, so prepare your paper and pen as I dictate. Okay? Let's start. Capital letter C, open parenthesis, small letter N, comma, small letter R, close parenthesis, equals, small letter N, exclamation point, over, small letter R, exclamation point, open parenthesis, small letter N, minus, small letter R, close parenthesis, exclamation point. Where capital letter C is the combination, small letter N are the different objects, small letter R are the objects taken from different objects N, and the exclamation point is the factorial. To read the formula is simply the number of combinations of n objects taken R at a time is equal to the n factorial over R factorial multiplied to the quantity of n minus R factorial. Let's have an example. Example number 1, calculate the combination of 5 taken 3. First, identify the given. N is equal to 5 and R is equal to 3. Then substitute to the formula. C n taken r is equal to n factorial over r factorial times the quantity of n minus r factorial. So we have the combination of 5 taken 3 is equal to 5 factorial over 3 factorial times the quantity of 5 minus 3 factorial equals 5 factorial over 3 factorial times 2 factorial. To simplify, let's expand the number having a factorial. 5 factorial means 5 times 4 times 3 times 2 times 1. And 3 factorial means 3 times 2 times 1. Times 2 factorial means 2 times 1. After, let's cancel out the common. So the remaining is 5 times 4 at the numerator and 2 times 1 remains at the denominator. So 5 times 4 equals 20 divided by 2 times 1, which is 2, is equal to 10. Very good. Therefore, the combination of 5 taken 3 is equal to 10. That's right. Example 2. In how many ways can a committee consisting of 2 members be formed from 6 people? Again, in how many ways can a committee consisting of 2 members be formed from 6 people? First, identify the given. N is equal to 6 and R is equal to 2. Then substitute to the formula. So we have the combination of 6 taken 2 is equal to 6 factorial over 2 factorial times the quantity of 6 minus 2 factorial equals 6 factorial over 2 factorial times 4 factorial. To simplify, let's expand the number having a factorial. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial means 2 times 1. Times 4 factorial means 4 times 3 times 2 times 1. After, let's cancel out the common. So 6 times 5 remains at the numerator and 2 times 1 remains at the denominator. Then 6 times 5 equals 30 divided by 2 times 1, which is 2, is equal to 15. Very good. Therefore, the combination of 6 taken 2 is equal to 15 or 15 ways. That's right. To assess our understanding, mga kastig, let's have a short quiz. I will give 3 minutes to solve these 2 problems. Solve the following. Number 1. Calculate the combination of C or combination of 4 taken 1. Again, calculate the combination of 4 taken 1. Number 2. A geologist wants to study the continents on the Earth's surface. In how many ways can a geologist select 3 continents from 7 continents for further research? Again, a geologist wants to study the continents on the Earth's surface. In how many ways can a geologist select 3 continents from 7 continents for further research? Time's up! Let's check your answer. For number 1, calculate the combination of 4 taken 1. The answer is very good, 4. How about number 2? A geologist wants to study the continents on the Earth's surface. In how many ways can a geologist select 3 continents from 7 continents for further research? Tama! 35 ways. Hawod o kuyaw jud niya itong mga kaastig ba? Murag 98.3 Gold FM, ang radyo astig ng tagong. Kuyaw, ano? For further learnings, always tune in to our school FB page and to our partner station, ang Gold FM. That's the end of our lesson mga kastig, and hopefully, we learned something new this afternoon. Thank you once again. I am your teacher broadcaster, Sam Nimel Jun B. Asakaan, saying, do not make simple things complicated, but make complicated things simple. Have a nice day. Bye-bye.
That was great! Thank you, Sir Nimel. And thank you, viewers and listeners, for tuning in. I hope you have learned something today. Once again, I am a teacher host, Sir Richard S. Binyas, saying, if math is hard, and so is life, then get over it. Have a nice day. Bye-bye!